Hello everyone, the problem that we're looking at today is the USACO 2023 US Open Contest Silver Problem 2 of Field Day. You can pause video first and look at this problem yourself. The problem statement is really straightforward, so I'm just going to say it here. Farmer John has at most 10 to the 5th power cows, and he has selected at most 18 cows, teams of cows, to participate in Field Day, and the breeds are given as n different strings. And now for each of the strings from 1 to n, you're trying to calculate the team with the maximum difference from this current team. And you're trying to output the maximum difference that exists between this team and any other team. So, for example, the first one, the maximum difference is between team 1 and team 3, which is 5, right? Because first spot, second spot, third spot, fourth spot, fifth spot, every single spot is different. So 5 spots are different, and the answer for the first one and the last one are all 5. While for the second one, you can at most have it be compared with, let's see. So the second team and the third team differ by 3, right? So the first spot is different, second is different, third and fourth are the same, and then the fifth spot is different. So now you can pause the video once again and think about this problem yourself. Once again, this problem is not very easy for a silver, but as of 2023 and US Open, I would say it's not that difficult either. In fact, I would say it's a really good one. So first of all, as someone who is already looking at this video, meaning you probably take USACO seriously, you should be able to realize that 18 is a special number in competitive programming, and as at least for USACO, it is the number for bitmask DP or any other type of algorithm that involves the time complexity of 2 to the nth power, because 2 to the 18th is, well, probably one of the biggest numbers that you can hold. While some other problems use 2 to the 20, I think 2 to the 18 is what USACO usually use. So for this problem, we want to guess a bitmask DP, just looking at this number of 18. So how do we utilize bitmask DP on this problem? Well, the only DP state that I was able to think of was probably FI, meaning the FI meaning the number with the least digit different from I. Oh yeah, I also forgot to mention, I would say you guys can probably figure this out on yourself, but a very smart trick in here is to replace every single character by 1 and 0. In my case, I used G as 1 and H as 0, and then we're just trying to find the maximum value after doing a XOR operation, bitwise XOR, right, like that. And then FI is the number with the least digit difference from I, because, well, if we do the most digits different, it's going to be quite complicated to deal with. And least digit, notice that you can really easily transform that to the answer because, well, you can just take the opposite of every single cow and then find the F of the opposite, because the number with the least digit difference from the opposite of I is the number with the most digits difference from I itself. But then how do we transfer using this state? Because notice how there is not a specific order we can do this. Well, I don't know if you guys learned this, but there is a trick of DP transferring called Q-aided DP transfer. Q as in Q-U-E-U-D. That Q, like a Q-aided DP transfer. I am not sure if you guys heard that before, but that's actually, well, you can use that in this problem. I guess you can call it a Q-aided DP transfer, but the process is actually not at all like what a regular Q-aided would be. But, well, for me at the time, it was kind of dumb. I just thought this is what Q-aided DP is. And what I did was I used the Q, just as the name suggests, and I pushed every single string that was in the input into the queue. And for each time we do a process that, now that I think about it, it's kind of like a BFS, in which case every time we pop the top of the queue and then we do a transfer by changing one digit, and then the distance from, so for each number next, the number with the least digits difference from next is going to be the first number that reached it, because, well, it's kind of like with BFS, because you only change one digit each time. The number that reached it first is got to be the one that changed the least digit, which is the one that's closest to next. So then you record F just like we recorded distance in BFS. And now that we found the array F using kind of like a BFS process, or I guess you could call it a Q-aided DP transfer, all we want to do is to find the opposite of every single string, and then we find f of that opposite. In this case, we just use a want array for what we wanted, and then AI sort this thing is just everything reversed, right? Obviously, because 2 to the c power minus 1 is just going to be c minus 1 continuous once, and then you do XOR on that, it's just reversing the whole thing. Then the f of 1 is however many digits. F of 1 is the number with the least difference from the reciprocal of AI. So then AI doing XOR with the reciprocal is just going to be the number. It's just going to be however many digits are 1 is however many digits that are different between AI and the number that is closest to AI's reciprocal, and with that farthest away from AI itself. And then we just took a built-in pop count, which is just a built-in C++ function which counts the number of ones in this number. And with that, you have a very short code, and you solve this USACO 2023 US Open Contest problem to a field day. So after all, notice that this problem, I would say, is a very interesting one for silver. Even though the C being 18 just give away a lot of information about it being bitmask DP, but if you can't think of the BFS-like process of Q transfer DP, you probably still wouldn't be able to solve this. So I would say its difficulty is on par with US Open of that time period, and considering it's problem 2, I would say it's a pretty good one. So hopefully after this video, you'll know how to solve the USACO 2023 US Open Contest Silver Problem 2 a field day. Thank you for watching, and I'll see you tomorrow. Okay, so that was a problem review for today. Now we come the grind report. So as you guys know, I'm grinding for platinum now, even though it's still in a few months. I still think I shouldn't be doing problem reviews over silver problems when I'm really doing gold. But, I did those problems, and it just feels bad if I don't do a video after doing the problem. So it doesn't matter. Anyways, that was a problem review. And the grind report today, I did some problem, actually, because I'm taking the class from the website of XYD, and then I got a bunch of homeworks. So today I did, on April 8th, I did 1, 2, 3 different XYD problems, and then 2 different templates. This one is, let's see it, P1631. I'm pretty sure it's just a regular heap template problem. And then you have the Lagrangian and the Lagrange interpolation. That's what this template is. It's called the Lagrange interpolation, which is not a common algorithm in which you find the equation for that passes through n points. You find an n-1 degree equation that passes through n points and the given points, and now you're trying to determine a certain value of a certain point on this equation. And it's an n-square algorithm, so kind of advanced, but not that useful. So yeah, and I was only able to do all these stuff today because, well, I didn't have school today. We had an ACT day, and obviously I'm not a junior. So yeah, that is the grind report for today. I would say for a no school day, I did not nearly enough, but still good enough because I did, 5 problems. And for each of those 2, I had 2 different methods actually to solve it. So I wrote 7 different code today. Good enough. Okay, thank you for watching. I'll see you tomorrow.